A couple things we're dealing with. We talked about complex numbers. We're going to talk about, and all we're really doing is we're building on what you know about numbers. So your irrational numbers, we said pi, square root of 2, square root of 3, all those things that we don't know perfect square roots. Those are going to be under your irrational numbers. And so we had rational, irrational, whole numbers, natural numbers, integers, counting numbers, all those, and then it builds, and eventually we get the imaginary number. Okay, so our imaginary number means we're talking about the square root of -1. And what that's going to be equal to is I. And so we have the square root of -1. Okay. So we have some history for you. A little bit of history. We're talking about Descartes. René Descartes, he's French. First one to use the term imaginary when we're talking about this. And really what happened was, he's trying to solve some things. They end up with the square root of a negative, and it's just not possible. Right? If you check it on your calculator, they're going to tell you that we're talking about an imaginary number. Okay? So 1637, Descartes says that's what we're going to call it. However, imaginary numbers were discovered much earlier, so back to the 1500s, but not widely accepted. So we go the whole way to the 1500s, and then it wasn't until 1707, actually later on, because that's when Euler was born, and 1777, when Carl Gauss started doing some things. So some really big names in math, and they had a lot of beginnings talking about the imaginary numbers, which is a huge part of complex numbers. All right. So what do you have to do with it? You don't have to do too much with it because you know a lot of stuff already. You know the square root of 4 you would do as 2 and 2. So if we talk about this, we're going to say -1, 2, and 2. So if we treat it that way, it's -1 times 2 times 2. You would never write this anymore because you're so far beyond this. You know the square root of 4 is 2, and if I have the square root of -1, and I don't need a pair for this, is I. So 2i would be the square root of -4. Okay, so the next thing we take a look at. So again, I can take care of my 8 as 2 and 4, 2 and 2. So you notice you have a pair of 2, so that's 2. I have a negative, so I say 2i, and I have a square root of 2 left over. So all the work that you've done on your square roots, we're just going to add in one extra thing. So if you see a negative, you get I outside of the square root. So again, we try a couple more. 45. Again, I can say -1 and then break that down as 5 and 9. So 3 and 3. So here's my pair of 3's. Here's my square root of -1, so I have I, and square root of 5. So 3i square root of 5. Square root of 28, and it is negative, so we'll say -1, 28. We'll do 4 and 7, and 2 and 2. So 2i square root 7. 2i square root 7. I know you're saying his square roots look like 5s, but trust me, I'm saying square root, and I'm writing it. I just write it really quick, that's all. All right, so a complex number, right? Because the whole thing is supposed to be about complex numbers. You said, oh, you said it so far, it was an imaginary number. All right, complex number means that we have a plus bi. A and b are real numbers, so that means it can be anything. We're talking about fractions, decimals, whole numbers, integers, so that means it can be positive and negative. And all we have to do is say we're talking about, we have a real part. So this means that we're adding or subtracting a real part and an imaginary part. That's what makes up a complex number. So they use the word complex to make you sound really intelligent, but all it means is we're going to have an imaginary number as part of it and a real number. And then after that, you're going to see how easy this is. You're going to love this section. Okay? So I have a real part and imaginary part. If I have that, we're adding and subtracting, then we call it a complex number. Ready? So here's your complex number. Watch how uncomplex this is. I'm adding, okay? Be careful. A lot of times we start the FOIL, but look for the sign first. We're adding. So all I'm going to do is I'm going to say 5 plus 3 is 8. And I'm going to treat these 7i and 2i just like they were 7x and 2x. They are just like any other like term. So 7 plus 2i, 7i plus 2i, so plus 9i. That's the whole thing. And you're saying, wait a minute, it can't be that easy. Well, with addition and subtraction, it is. Okay, so I have 6 minus 4 is 2. Then I have 3i minus negative, so that means plus 3i plus 2i, so plus 5i. Alright, now remember I said in the beginning it is that easy. Here's the next part. What's going to happen when I multiply? Right? If I multiply 5x and 4x, right, I would have 20x times x, or 20x squared. Alright, so here's where it gets just a hair tricky. So I'm going to have 20I squared. Remember, I'm going to treat that I just like any other variable. So we said x squared, so it's I squared. Okay, so here's the deal. I'm talking about 20, and I'm going to change this back just one time to show you what's going on. So this means I'm talking about the square root of -1 twice, right? Because I have the second power. So that means I'm squaring it. So 20 square root of -1 squared. Well, you know the square root and the square, they cancel each other out. So that means I really have 20 times -1, so my answer is -20. Alright, so we got 5i times 4i. We end up with a final answer of -20. Okay? So the bottom line, when you take a look at that, if I have I squared, that's going to be equal to the square root of -1 squared, which is plain old -1. So here's the part you really need. Anytime you run into an I squared, you change it to -1. Alright, so now our fourth example, we're talking about this. We said we're going to treat it just like any other variable, so now there is no sign in here, so we do have to FOIL it. So first, I get 8. Outside, I have plus 14i. Inside, I have plus 12i. And on the last part, I've got 7 times 3 is plus 21i squared. And here's what we just said. Anytime I have I squared, replace it with -1. So I got plus 21 times -1. I have like terms, right? Just like any other variable, I and I. So I got 14 plus 12, so that's 26i, and plus 8. All right, let's clean this up. This actually becomes minus 21. I've got 26i, and I've got a positive 8. Like terms again, 8 minus 21. I have negative 13 plus 26i. Now this is where it's also a little bit backwards. When we're talking about if this was x, I would want you to say 26x, and then we would say minus 13. When we're talking about a complex number, right, I have a real part and an imaginary part. Complex number, I'm always going to write the imaginary part second. So write that second. So FOIL, big key, right here. I squared becomes -1. Alright, let's try that again. Let's go with the yellow again. Alright, so I got 15. I've got plus 3i. You've got minus 10i. And we all have minus 2i squared. So maybe when you write that I squared, you just put it in parentheses like that. So you like terms in the middle. I got 15. I got minus 7i. And I've got negative, so minus 2 times -1. Once you do these a couple hundred times, you realize just to write this as plus 2, minus 7i, and 15. Right, so I got 15 plus 2 is 17, minus 7i. Complex number, imaginary term goes second. 17 minus 7i. Done. Alright, so now we're going to solve. And you're saying, what in the world does this have to do with what we just did? Well, watch this. We're going to solve, right? Minus 100. The idea, I have this x squared. I want to get it all by itself, and then to get rid of the square, I'm going to take the square root of the 1/2 power. So I get 4x squared equals -100. Divided by that 4. So the x squared equals -25. Aha, now you're saying, yep, that's why. So I'm going to take the square root of both sides. So what's the square root of -25? Well, the square root of 25 is 5. The square root of any negative is I. So final answer is x equals 5i. And keep in mind, we don't have two variables here. because I is actually the square root of negative 1. Alright, let's solve it again. So we know we're going to subtract 48, so 3t squared equals negative 48 divided by 3. T squared equals negative 16 square root. T equals square root of 16. You guys know this, it's 4. Square root of negative 1 is I. T equals 4i. Alright, so example 3, here we go. We're going to add the 5. So 4x squared equals negative 128 divided by 4. Okay, so x squared equals, I got negative 32. I'm going to take the square root. So x equals, we got to break this thing down. I know I'm going to have an I. So how are you going to break down 32? Most of us would say what? 4 and 8. And they would say 4 and 2, and 2 and 2, and 2 and 2. 1, 2. So I got 4 I root 2. Okay. X equals 4i square root 2. 4i square root 2.